Hello everybody. So today we're going to take a look at the next section in chapter 7, which is still going to be using or still going to be solving systems of equations, but this time we're going to take a look at a second method to solve it, which is called elimination. Okay, so to use elimination to solve these systems, we have to understand that we can solve or we can add or subtract equations just like we can add or subtract numbers. Okay, so for example, if I had something like this equation, and to it I can add another equation like so. So I'm adding this entire equation to the first one. So when I do that, notice that I have all of the like terms vertically lined up. So here we'd have 2x plus 4x, which of course would give us 6x. And then here I'd have 5x plus negative 3x, or sorry, 5y plus negative 3y, which would give me 2y. Then I have 3 plus 2, which would be 5. Okay, so that would be the new equation if we added those two. And of course we could also subtract them. So I had something like, negative 2x minus y equals 6. And I could subtract from it something like 5x minus 3y equals 1. I could subtract this whole equation. And if I do that, well, I'd have negative 2x minus 5x would give me negative 7x. Negative y minus 3y would give me positive 2y, and then 6 minus 1 would be 5. Right? So pretty straightforward, I hope. So when we're doing this method, the number one goal that we're trying to accomplish using the elimination method is to cancel out one of the variables when we either add or subtract. It's up to you whether or not you want to take the two equations in the system and add them or subtract them. It doesn't matter which way you decide to go, just as long as you do it correctly. Okay? And what I mean when I say to cancel out, I mean that whatever we add or whatever we subtract for one of the variables should equal 0, right? So if we get an answer of 0x or 0y, then of course that variable doesn't exist anymore. It cancels out. Okay, so what we're going to do is I'm going to give you an example here, and we're going to consider this system. We're going to do 2x plus y equals negative 7, and we're going to do x plus y equals negative 4. Okay, we're going to solve this system. So pretty much every time you use elimination for any of these questions, you'll be able to cancel out either the x or the y. It doesn't matter which one you decide. One will usually be easier than the other. So in this case, we take a look here. We have 1y in the first equation, and we have 1y in the second equation. So what are we going to need to do with these equations? Are we going to have to add them, or are we going to have to subtract them in order to get the y's to cancel out? Well, if we added both of these equations, like so, we would get 3x plus 2y equals negative 11. So notice here that none of the variables canceled out. We still have 3x and we still have a 2y. So clearly what we're going to have to do here is we're going to have to subtract them instead. So when we do that, we get 2x minus x, so that just leaves us with 1x. And here we have 1y minus 1y, which of course gives us 0y, right? And then that will be negative 3. So what we end up getting is x equals negative 3. And that's half our answer, right? We have the solution to one of the variables. We know that for that system, x is just equal to negative 3. So now all we have to do to get the other variable is we just do what we did in substitution. We can substitute that x into either of the original equations. So I'll take the second one here. I'll do x plus y equals negative 4. And because I know x is equal to negative 3, I'll just come over there. And I'll make that substitution. Right. So I want to get the y by itself. So all I have to do is add 3 to both sides. That way the negative 3 on the left will cancel out. Right. So I'll get an answer of y is equal to negative 1. So therefore the answer is x equals negative 3 and y equals negative 1. Okay, so you see how the y's canceled out there. That was the trick we need to do. Let's take a look at a second question. And this one's going to involve an additional step. So if we have something that looks like this, we'll do 3x minus 4y equals 7 and 5x minus 6y equals 8. Okay. So the main difference in this system compared to the last system is that in the second system, there's no variables that share the same coefficient, right? There's a different coefficient in front of both the x's, and there's a different coefficient in front of both the y's. So no matter what we do, if we add these two equations together, or if we subtract these coefficients from, or these equations from one another, there's no way for us to get either the x's or the y's to cancel out. So we're kind of stuck. So what we have to do now is we're going to need to multiply these equations by some number so that we do end up getting one common coefficient for the same variable in this system. Okay, so in this example, what we're going to have to do is multiply the equations by a constant. to make one of the variables coefficients equal to the original coefficients lowest common multiple. Okay, then I'll show you what I mean by that. So we can pick X or Y here. It doesn't matter which one you want to start with. I'll just use X. Okay, so I'll take a look at my coefficients for my X variable. So the first one is a 3, and the second one is a 5. So if we list out our multiples here, going up by 3s, of course, eventually we will find our lowest common multiple, which of course between 3 and 5 is 15. So that means what we're going to do is we're going to pick a number to multiply the entire equation by to make that x 15x and this x 15x. Okay, so for the first equation, 3x, so to go from 3 to 15, of course we need to multiply by 5. This is going to be times 5 for the 3. And to go from 5x to 15x, we're going to need to multiply by 3. Okay, so I'll take the original equations for both. So 3x minus 4y equals 7. And I'm going to multiply the entire thing by 5. Alright, so that means I use my distributive property here. And I'm going to do the exact same thing with the other equation. It's 5x minus 6y equals 8. And just like we said, we're going to multiply the entire thing by 3. Okay, so when we do that, we get 3x times 5, 15x. Negative 4 times 5 is negative 20. And 5 times 7, 35. And over here we get 15x as well. Negative 18y. And 24. Okay, so now notice that the coefficients for the x variables for both of them are the same. That's the goal we're trying to do, or that's the goal we're trying to make here. So now all we need to do is use the method from the previous question in order to solve it, because now we're at that point, right? So I'll stack these up. 15x minus 20y equals 35, and 15x minus 18y equals 24. And the question is, are we going to have to subtract these two equations to have the x's cancel out, or are we going to have to add them? Well, if we added them, the first thing we would do would be 15x plus 15x, which would of course give us 30x. So the x's would not cancel in that case. So we're going to have to subtract, because when we do 15x minus 15x, of course, that is 0x, and it cancels out. Right? After that, we get negative 2y right? And 35 minus 24 is 11. So we get negative 2y equals 11. And then we can just solve for y. So from there, we have to do is divide both sides by negative 2. When we do that, the 2's cancel. And we're left with y is equal to negative 11 over 2. Right? So that's half the answer. We need to find out what x is going to equal from there. So we can go back and grab one of the original equations. So we can just take 3x plus, or sorry, minus 4y equals 7. And we can drop that y right into that y right there. So we'll make that substitution like that. So we'll get 3x minus 4 times 11 over, or sorry, negative 11 over 2, 7. And we just solve for x. So what that's going to be minus negative 22, 7. So subtracting a negative 22 is the same thing as adding a positive 22, right? Right, then we get 3x. So, well, I guess I'll write out the step here. So we want to get that x by itself, so we want to subtract that 22 from both sides. Right? That cancels when we do that. So we get 3x is equal to negative 15. And then from there, we'll divide by 3 on both sides to get rid of that 3. Those 3's cancel out, and we are left simply with x is equal to, well, negative 15 divided by 3, of course, gives us negative 5. All right, so therefore, x equals negative 5, and y equals negative 11 over 2, which is the same as negative 5.5. All right, so exactly the same thing, exactly the same method as the last question, except we had to go in and we had to multiply them by a constant to make sure that the coefficient was the same across the same variable. Okay? So hopefully that's not too bad. So what I'll get you guys to do is to work on the homework. So for this week, it's going to start on page 437. And I will get you to do questions 3 to 8. We'll just do that for this week, okay? So go ahead, give those a shot. Make sure you email me or contact me through the Discord if you have any questions. I can always come and I can help you out. So as always, stay safe, and I'll see you guys next week. Bye.